Okay, so let's talk about the product rule. The product rule is for when you have two functions that are multiplying together, but you can't really simplify them. You could let's get into it. So you've got y, u, and v are all differentiable functions. That means that they're not like piecewise or something crazy. Don't worry too much about this. We can get into it more later. Of x, and if y equals u times v, then this is the rule. The derivative of y with respect to x is the function u times the derivative of v with respect to x plus the function v times the derivative of u with respect to x. So let's look at an example. Okay, I took this right from your book because I know that sometimes it's nice to be able to reference that. So this is example 12 on page 446. Okay, so we have two functions that are being multiplied. Could you just distribute these and simplify? For surezies. And in fact, we're going to use that to double check our work. But before we do that, we're going to use the product rule. So in this case, here's our y, and I'm just going to highlight that in white. And then we're going to say that we have the function u, which is this one right here, and the function v, which is this one here. What we're going to do is we're going to take u and multiply it by the derivative of v, and then v and multiply it by the derivative of u, and that is going to get us our correct one. There is a proof of this on page 445 if you want to see that, but this is one of those things that we're kind of having to barrel through a little bit. So just over on the side here, I'm going to write out what our functions are. So we're going to say u is x squared plus 2x, and then du dx is going to be 2x plus 2. Give myself just a little bit more space now. V is 1 over x plus 3, and then dv dx is going to be negative 1 over x squared. And again, this comes from the fact that I could rewrite this guy as x to the negative 1. So that negative comes down and multiplies, and then you subtract 1, it becomes a negative 2, so it's that. Let me know if you have trouble on that. Okay, so then it's literally just following this formula, which does make sense, and there is a reason for it, but let's give ourselves a little space, and we're going to do that. Okay, so y is going to be equal to u, which is x squared plus 2x, times the derivative of v, so that's going to be this guy. So negative 1 over x squared plus v, which is going to be 1 over x plus 3, times the derivative of u, which is 2x plus 2. Now, there's a whole lot of stuff happening here, so I'm going to just simplify a bit. So I'm just going to be distributing, and I'm going to do that off of recording. Okay, just distributed that out. This got us negative 1. This got us negative 2 over x. That got us 2 over x, 6x, 6. And then we can combine like terms. And I'm just realizing that this should have been dy dx because we're calculating the derivative. Okay, so we're left with just this. Okay, how could we double check that this magical formula that I gave you actually works? Well, what if we distribute to begin with and then just get those derivatives? So I'm going to move this over here, and let's do that. So let's double check ourselves. Well, if we distribute here, we're going to get, that's just going to become a single x. So y is just going to be x. This would become a plus 3x squared. This would become just a plus 2. And then this would become a plus 6x. And then we can start combining like terms. We've got a 3x squared. There's only one x squared term. There's an x and a 6x, so that gets us 7x, and then a plus 2. And then if we just found the derivative, we would get 6x plus 7. Hey, check it out, this and this match. Cool, so that works. And many of you are like, dude, why didn't we just do this thing to begin with. Absolutely, I would expect most of the time you would do this, but pretty soon we're going to end up with things like y equals x squared e to the 4x. And then you have this function multiplying by this function, and we can't combine them anymore. Like, there's no way for us to combine them. So we're just using things that we know how to do in order to do that. My suggestion here is just be really clear what's u, what's v, and then write out the derivatives. I know this might feel excessive, but this really isn't too much for y'all to write, and it will help you be a little bit organized. Once you get used to it, things will be much better. Very important to note, it is not just the derivative of this times the derivative of this. It's slightly more complicated than that. If you want to know why, then I would suggest you look at the proof of the product rule on page 445. That might help enlighten things. If it doesn't, let me know. I'm happy to help out. So here's the product rule. I'm going to give you guys a couple of practice questions, and I will make answer keys for those as well.